Latent heat. Try this. 1. Take a few pieces of latent heat. Try this. 1. Take a few pieces of ice in a glass beaker as shown. 2. Insert the bulb of a thermometer in ice and measure its temperature. 3. Put the beaker on a stand and heat the ice using a burner. 4. Record the temperature using the thermometer after every minute. 5. As the ice is heated, it starts melting. Stir the mixture of ice and water. 6. Continue the heating even after ice starts melting. 7. Draw a graph of temperature versus time. You will observe that the temperature of mixture remains 0 degrees Celsius till the ice melts completely. If we continue heating even after conversion of all the ice into water, the temperature of water starts rising and reaches 100 degrees Celsius. At this temperature, water starts converting into steam. The temperature of water remains constant at 100 degrees Celsius till all water converts into steam. Observe the graph of temperature versus time. In this graph, line AB represents conversion of ice into water at constant temperature. When ice is heated, it melts at 0 degrees Celsius and converts into water at this constant temperature. The ice absorbs heat energy during this transition, and the absorption of energy continues till all the ice converts into water. The constant temperature at which the ice converts into water is called the melting point of ice. Thus, during transition of solid phase to liquid, the object absorbs heat energy, but its temperature does not increase. This heat energy is utilized for weakening the bonds between the atoms or molecules in the solid and transform it into liquid phase. The heat energy absorbed at constant temperature during transformation of solid into liquid is called the latent heat of fusion. The amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid phase is called the specific latent heat of fusion. Once all the ice is transformed into water, the temperature of water starts rising. It increases up to 100 degrees Celsius. Line BC in the graph represent rise in temperature of water from 0 degrees Celsius to 100 degrees Celsius. Thereafter, even though heat energy is supplied to water, its temperature does not rise. The heat energy absorbed by water at this temperature and used to break the bonds between molecules of the liquid and convert the liquid into gaseous state. Thus, during transformation from liquid phase to gas phase, heat energy is absorbed by the liquid, but its temperature does not change. The constant temperature at which the liquid transforms into gaseous state is called the boiling point of the liquid. The heat energy absorbed at constant temperature during transformation of liquid into gas is called the latent heat of vaporization. The amount of heat energy absorbed at constant temperature by unit mass of a liquid to convert into gaseous phase is called the specific latent heat of vaporization. Different substances have different melting points and boiling points. The values of melting point, boiling point, and latent heat depend on atmospheric pressure.
So I hope students that video was quite clear to you. Let's understand what is latent heat. Now the word latent in English means hidden, छुपा हुआ है. Okay, okay, latent heat. Now during the transition or transformation of a substance from solid to liquid phase means state, the object absorbs the heat energy, but its temperature does not increase. As I told you, no, till all the ice melts into water, or till all the liquid water gets converted to steam, the temperature will remain the same. Till all the ice turns to water, the temperature will remain 0 degree only, as you saw in the video. Okay, but temperature does not. This heat, so what happens, so what is this heat used for? If it is not showing increase in temperature, what is the use of this? Is this heat is used for break or for weakening the bonds between the particles, whatever atoms or molecules are there in that solid, and to transform it or change it into the, or convert it to the liquid state. Okay, we all have learned, no, that in the when the bonds are broken, weakened in a solid, you know, no, the particles of the, in a solid, all the particles are very closely packed. In a liquid they are slightly away, whereas in a gas they are very much far away from each other. So when the bonds are weakened, the particles move little away from each other, and so the solid gets changed into liquid. I hope it is clear. So I remember, till the whole ice gets converted to water, the temperature will remain at 0 degrees Celsius only. It will not change. So also, let's say iron, till the whole iron changes from solid to liquid, the temperature will remain 1535 degrees Celsius only. It will not change. Okay. Next, the heat absorbed at constant temperature during the change of solid into liquid is called the latent heat of fusion. Fusion, as I told you, fusion means melting. Okay, fusion means melting. In physics, fusion means melting. In your songs and all, when say fusion song, fusion, there it is all mixed. When two, three songs are joined together, we call it fusion. Fusion music, fusion. But here in physics, fusion means melting. So, what is the latent heat of fusion for ice? It is 80 calories per gram. So, each gram of ice will absorb 80 calories to change from solid to liquid, from ice to water. During the transition from liquid to gaseous state, now I'm talking about liquid to gaseous, and before this I spoke about solid to liquid. Liquid to gaseous state, the heat energy is absorbed by the liquid, but again the same funda, its temperature does not change. Okay, the temperature will not change. So till 100 degree, once the temperature reaches 100 degree, and then what will happen, the temperature will not rise at all till the all the water is converted into steam. Okay, now this heat, what is it used for? It is used for breaking the bonds. So now the bonds are broken again. So what will happen, the particles, the atoms or molecules or particles of that of that liquid will move away from each other. That means there will be a lot of gap between them. So what will it change? Which state it will change? It will change to a gaseous state. Okay, it will change into a gas. So is it clear? Now, the heat absorbed at constant temperature during change of liquid into gas is called latent heat of vaporization. Okay. Now, what is it is 540 calories per gram for water. For different substance, it will be different. So, for water, so in other words, what does it mean? It means that each gram of water will absorb, it has to be provided 540 calories of heat in order to get converted into steam. Again, what I understand, as I told you, when anything is converting from solid to liquid or liquid to gas, when once, okay, it will, the temperature will not change. Though you are supplying the heat, the temperature will not change. That heat which you are supplying, that becomes your latent heat. Okay. So I hope this particular concept of latent heat is clear to you all. Okay. So remember, once again I'm repeating, till all the ice gets converted to water, the temperature will remain of the ice will remain at 0 degree. Though you are heating or it is absorbing heat from the air. So also till when you are boiling water, once the water reaches 100 degree, when you are boiling from room temperature it reaches 100 degree, till all the water is converted to steam. Though you are supplying the heat, the temperature of the water will remain at 100 degree Celsius till the whole water gets converted to steam. Okay. So in other words, the steam is absorbing the water is absorbing the heat, but there is no rise in the temperature. That becomes stored as latent heat. That is the reason I told you. Remember that why the burns which are caused by steam are more severe or more bad than the burns which are caused by boiling water. I told you about, if I throw steam on your face and I throw boiling water on your face, that boiling water will not cause you so much harm, but the steam will cause you a lot of harm, to disfigure or burn your face very badly, thanks to the latent heat. I hope this is clear to you all. Let's move to the next slide.